right, so this is part two, and this is I kind of hate to peel back the curtain, but I think it's important. It's okay. You can understand this. Instead of just like you need to know this, I think it's important to understand the behavior of atoms. And so, a really important property of atoms is something called electronegativity. And electronegativity is the attraction of the nucleus. Remember, nucleus has positive charges, and so positives attract opposite charges, those negatively charged electrons in the bond. So atoms form bonds, and the attraction between the atoms in the bond with the electrons is called electronegativity. And there are varying degrees of strength of attraction. And that varying degrees of strength sets up covalent or ionic bonds. Now, the periodic table has some trends. Now, this is a different looking periodic table. It does have atomic number, but then you'll notice those numbers below don't look like atomic masses or atomic weights. That's because they're not. So these are relative numbers that define the electronegativity, the attraction for electrons in a bond across the periodic table. So if we look at this, you can see some numbers. So fluorine F in the upper right hand corner there has the highest electronegativity of 4. It's the most electronegative. It really likes electrons in bonds. It forms really strong acids is what it does. You'll learn about that next year in chemistry. Hydrogen has 2.1. That's a pretty electronegative. It likes its electrons, no question about it. There are some patterns and trends, and you just need to be aware of this as you go. And these are trends. It's not like absolutes. As you go up, so as you go from row 7 up to the top, it tends to increase a little bit. And certainly as you go from left to right, you look at the numbers. Pause and just look at the numbers. You'll notice that fluorine in the upper right-hand corner, chlorine right over there, really highly electronegative. They like their electrons. All right, so what does that do? Well, that sets up some interesting relationships. If we had a tug of war here between two people, these people are equal size, equal strength, and their relationship would probably be a stalemate. So think about atoms. So atoms with a tug, an electronegative tug on electrons, the bond that they create is equal. Well, what if you have a couple other atoms, and one of the atoms is a little bit larger than the other one? Well, it still needs to get to that octet rule. It's going to form a bond, but it's going to be an unequal sharing of electrons. That's electronegativity. All right, so let's look at some numbers. So you saw some numbers on that periodic table, right? So if we have a difference between electronegativities between 0 and zero point 0.5, it's not that big a deal. You know, the match is pretty equal between the tugs of those atoms. But as one atom gets to be a little bit larger or getting closer to the octet rule, it has a really strong pull. And as a matter of fact, if it's really, really strong, it'll change things altogether. It'll start ripping electrons off of there. So anyway, there's some numbers that we're going to consider looking at some examples. So if we look from the chart, so we go back to that periodic table, and we see that hydrogen has an electronegativity of 2.1. Well, there's the difference between 2.1 and 2.1 is 0. So there's an equal sharing. If we look at the methane molecule, hydrogen 2.1, carbon 2.5, a difference of 0.4, still not that great, not that big a deal. And so we have a relatively equal sharing of electrons, and so not very electronegative here. But if we look at water, and remember hydrogen is 2.1, oxygen is 3.5, you can find that on that table up in the upper right-hand corner. We have a difference of 1.5. There's a sharing. It's still something we call a covalent bond. But the sharing is unequal because oxygen is like 8 times bigger than hydrogen. So it has a stronger pull on the electrons of the bond. So who really cares? Come on, Mr. P, who cares? Well, I think it's important to think about in terms of the way molecules and compounds interact with one another, and in terms of their polarity or non-polarity. So polar, don't think like cold, think polar like North and South Pole of the Earth, or a magnet, or maybe even a battery. So opposites. So if the electronegativity is between 0 and 5, it's a nonpolar attraction, right? So not much difference. But if we have a bigger difference, then we wind up with a polar covalent bond because the electrons are spending more time on one of the atoms in the arrangement. And so hydrogen is nonpolar, right? 2.1, 2.1, 0. Oxygen, we saw 3.5 and 2.1, so 1.4. So we wind up with the electrons of hydrogen spending more time with oxygen because it's so much bigger. And so that means that hydrogens on the water molecule are slightly positive and the oxygens are slightly negative. So it creates a polar covalent bond. It's a sharing, but it's polar. Now, ions are something different where the electronegativity between two atoms is really different, like hugely different. It's like greater than 2. And so we wind up with actually electrons being gained or lost. And what happens then is that we wind up with actually charges on the atoms, complete positive or negative charges. So here's a case of sodium chloride. Sodium is losing an electron to chloride, and sodium has 12. It loses one, so now it has one more positive charge, one more proton than one more electron, and so it becomes positive. Chlorine, on the other hand, had 17 electrons and protons, so it was neutral, but it picked up an electron, so now it has one more electron. Now it becomes negative, and that creates the ionic bond, that attraction between there. So here's another look at that. So here's sodium. You can count the electrons, right? So there are, it has, and we can look at the numbers too. So it has electronegativity value. It's in the upper left-hand corner of 0.9. Chlorine in the upper right-hand corner, pretty electronegative, right below fluorine. It has a value of 3. And the difference is 2.1. That means it's going to be an ionic bond. It's hard to say, an ionic bond. So sodium gives up its electron to chlorine. It makes sodium positive, chloride negative, and there's the attraction, and that's the ionic bond between those. All right, so covalent bonds. Here's just a nice flow chart. Covalent bonds, you can share things equally or unequally, and that's how it sets up nonpolar molecules or polar molecules. We also have ionic bonds, which transfer electrons, and they create positive or negative ions, and that creates the bond between those. So electronegativity and bonding, kind of overdone, but it's really important to understand how molecules work in biological systems. Hope that helps.